Okay, this is the next question. So according to the description given in the question, if I want to explain you, there is a figure given and we have one glass slab or slab whose refractive index is N2, the outside refractive index is N1, and according to the description, two rays of light incident on the first face, on this face. This is ray 1 and this is ray 1, this is ray 2. The ray 1 falls at point 1 and ray 2 falls at point 2. Okay, so they will definitely suffer refraction and they will enter into the medium. Now according to the question, both the rays of light, they meet at point 3. Okay, they meet at point 3. Now once they meet at point 3, what happens? They have traveled the whole distance of the glass slab. Therefore we have to calculate the width of the glass slab. Okay, well, and some data are given. The distance between point 1 and point 2 is equal to 4 multiplied by square root of 3. Theta 1 equal to theta 2 equal to cos inverse of n2 by 2n1. Okay, all right. Well, what is this thickness? This thickness is nothing but the distance between this point and this point. Okay, so how we will approach this problem? Let's apply Snell's law first. For this ray, let's say this angle is equal to r, angle of refraction. Okay, what is the angle of incidence? This angle is theta 1, so angle of incident, which is this one, will be equal to 90 minus theta 1, complementary. This angle is theta 2, therefore this angle of incident will be equal to 90 minus theta 2. These two are the corresponding incident angles, right? All right, let's apply the Snell's law on the first one. So this is n1 sine of incident angle, which is 90 minus theta 1, should be equal to n2 multiplied by 90 and n2 multiplied by simply angle of refraction, which is r. Now n1, what is 90 minus theta 1, sine of 90 minus theta 1? This is cos of theta 1. Okay, and this is n2 multiplied by sine of r. But what is the value of theta 1 or theta 2? It is equal to cos inverse of n2 divided by 2n1. Okay, so n2 sine of r, so this is equal to n2 n1. Cos and cos will be identity and therefore this will be n2 divided by 2n1 equal to n2 sine of r. N2 gets cancelled, n1 gets cancelled, so sine of r will be equal to half. What does it imply? It implies r equal to 30 degrees. So what is the angle of refraction? 30 degree. After calculating the angle of refraction, which is 30 degree, we have to calculate the distance from this point to this point, right? Let's say this point is 1, right? Let's say this is A, this is B and this is C. Okay, what is this BC? This point C is nothing but it is the middle of, it is the half of this point distance between 1 and 2. Okay, so this BC is nothing but d by 2. This distance is d by 2. Okay, this whole distance is d. Clear? All right. And what is this distance? This AB is nothing but the thickness of the glass slab. So we will apply the tan ratio. So tan ratio is equal to tan of the angle is equal to BC divided by AB. This is equal to tan of 30 degree, which is equal to d by 2 multiplied by AB is t. So this is 1 by square root of 3. This 4 square root of 3 and 2 multiplied by t, right? So this 2 and 4 will be cancelled, so this will be equal to 1 by square root of 3 equal to 2 square root of 3 then t. All right. So if I do the cross multiplication, this will be 2 multiplied by square root of 3 into square root of 3, which is 6. So answer is 6 centimeter. Okay. Now let's move to the next question. Question again is talking about the fractional compression, and we have to calculate the fractional compression in terms of percentage. The question is from properties of fluids. What is given? Let's read out that the bulk modulus of the water is given and the density of the water is given, we have to calculate the fractional compression, right? So let's write down the bulk modulus formula. Bulk modulus is equal to minus of the pressure divided by del V divided by V, minus of this, okay? And we have to calculate this fraction at a depth of 2.5 kilometer. Let's say this is the water, okay, and from the top we have to calculate this fraction at a depth of 2.5 kilometer, okay, 2.5 kilometer. Now we know that at a depth, what is the hydrostatic pressure? The hydrostatic pressure is given by H rho g. This is the hydrostatic pressure, okay. Now I will take this fraction del V divided by V here, and we will ignore the minus sign, then P divided by B. This is hydrostatic pressure H rho g and divided by bulk modulus, okay. Now let's put the value in SI unit. The depth will be equal to 2.5 into 10 power 3, okay, 2.5 kilometer. So I convert this into meter. The density in SI unit is given by 10 power 3 kilogram per meter cube, and the acceleration due to gravity is 10. What is the bulk modulus of elasticity? The bulk modulus of elasticity is 2 divided by 10 power 9, okay, 2 divided by 10 power 9. Therefore, if I continue the calculation here, so this will be 2.5 divided by 2, and then this is equal to 10 power 7 into 10 power minus 9. This is equal to 1.25 into 10 power minus 2, okay. Alright, after that this will be equal to 0.0125, and since we have to express this fraction in terms of percentage, therefore when we multiply this in terms of percentage, it will be equal to 1.25%. We have to multiply 100, okay. So the answer will be equal to 1.25, okay. Alright, let's move to the next question. Alright, the question is from the modern physics, from the de Broglie topic, and we have to identify the correct variation of 1 by kinetic energy with that of the de Broglie wavelength. So for a particular particle, the de Broglie wavelength can be written in terms of the kinetic energy like this: h divided by 2m multiplied by kinetic energy. If a particle whose mass is m and if it is moving with kinetic energy k, the de Broglie wavelength is written like this, okay. Now let me square both sides. So this will be equal to lambda square and h square 2mk, and we understand that this lambda square is inversely proportional to 1 by k. Now since the graphs are mentioning 1 by k, right, therefore I will consider this 1 by k to be a variable, and therefore if I consider this 1 by k to be y, okay, and this lambda to be x, then the equation that will govern this graph will be y proportional to x squared, right. You see, in all the graphs we have 1 by k along y-axis and lambda along x-axis. Therefore, if I consider 1 by k to be y, so this will follow a parabolic graph, okay, and this will be the correct graph, right. Now let's move to the next question. Okay, so we have one logic gate, quite easy. We have to identify the gate. There are two ways to identify this gate. Number one, we can write down the truth table for each of the gate, okay, and we have to check which one will give the correct output. So the second process is that we will write down the output and then we will solve it using Boolean algebra. Let's do it. See, in this logic gate we have one NAND gate, one NOR gate, and then again we have one NAND gate. So this one, the first NAND gate will give the output which is A dot B bar. This one will give the output which is A plus B bar, okay, and both will be fed to the final NAND gate, which will be the final output. So this will be A dot B bar dot A plus B bar. Again we have one bar like this, right. Let's simplify this. A dot B bar, and if I write down it like this, A bar plus B bar. So I have expressed this A dot B bar in terms of A bar plus B bar using De Morgan's theorem. Okay, and then this one A bar B bar. Okay, then let's multiply. So this will be A bar dot A bar B bar plus B bar A bar plus B bar. Then A bar multiplied with A bar, what will be this? This will be A bar only, right? B bar, and this B bar multiplied with B bar will be B bar, and this is A bar. Now, to same boolean, to same digital variable when added, it will give the same thing, right? So this is A dot B bar bar. Okay. Now again, I will convert this one in terms of A plus B using De Morgan theorem. It will give me A plus B. Then we have double bar, so this will give me A plus B. What is this? This is OR gate. So what is the answer? Answer is OR gate. Now let's move to the next question. Alright, so this is the next question. So in this question, what do we have? We have a body of mass m. Okay, it is connected to a massless an unstretchable string which goes in a vertical circle. Okay, vertical circular motion under gravity, and then it is mentioned that at the top of the path, the speed of the particle is n multiplied by g square root of gr, where n is more than 1, okay, more than or equal to 1. We have to calculate the ratio of the kinetic energy between bottom point and the top point. Let's try to draw the situation. Let's say this is the suspension point. The particle is suspended like this, and then the particle would go in a vertical round like this under gravity. Now this distance is nothing but r. This is the center of the circular motion and also the suspension point. At the vertical point, the velocity is given. Let's say this is v, and at the bottom point, let's say the velocity is equal to u. Okay, so we have to calculate the ratio of the kinetic energy of this to this. Now this velocity is known, but this velocity is not known. So we have to calculate this velocity. We will use the equation of motion. We will use simply v square equal to u square plus 2as. We can also use the conservation of energy also to solve the same. Okay. All right. So what is the final velocity here? At the top, the velocity is n square root of gr square. This velocity has to be calculated, u square. Then acceleration due to gravity is minus, and since the body is going up, displacement is plus. So from this point till this point, what is the displacement? Body is going up, displacement is plus, right? So this displacement will be equal to 2r. So this is 2r. So this is n square gr equal to u square minus 4gr. Alright. So u square will be equal to n square plus 4 multiplied by gr. Now let's calculate the ratio of the kinetic energy. So kinetic energy at the bottom divided by kinetic energy at the top. Okay. Bottom to the top. So this is half of m multiplied by u square divided by half of m multiplied by v square. This gets cancelled. What is u square's value? U square is n square plus 4 multiplied by gr, and v square is n square gr. Okay, so gr gets cancelled, and we are left with the answer n square plus 4 divided by n square. So this is the okay. Alright, the next question is as follows. We have to identify the correct variation between object distance and image distance of convex lens. Okay, quite easy one. Well, for a convex lens, we know that it will follow this equation 1 by v minus 1 by u equal to 1 by f, or simply u plus f, v minus f, and then equal to f square. Okay. So this will follow one inverse relation, and this is the correct variation. Okay. Well, if you know the image formation diagram of convex lens, still you can identify this. Okay. How? You see, this is my object distance. As the object distance decreases, the image distance will increase. Okay, image distance will increase. So see, up to the focus, up to the focal point, if you decrease the object distance, by the way, object distance is negative by ANSI sign convention because this is on the minus x-axis. But image distance will be positive because this is on the positive x-axis. Okay, come back to the logic. When you decrease when you keep on decreasing the object distance, image distance will increase. So you decrease the object distance, image distance will increase. But when you keep the object right at the focus, immediately the object will be disappeared. So when you keep the object here at the focus, what is the corresponding image distance? It will be at infinity. When you keep the object inside the focus, then again it will come and it will follow this kind of trajectory. So this is the complete variation. Okay. All right. I hope this is clear. So let's move to the next question. Again, one assertion reason question. I think not assertion reason. We have to match list 1 with list 2. Let's do it. The first statement is electric field inside a uniformly charged spherical shell of surface charge density sigma and radius r is equal to what? We know that for spherical shell and as well as for conductor, inside electric field is always 0. So this A will be with, this A will go with 3. This A will go with 3. Then electric field at a distance r more than 0 for a uniformly charged infinitely plane sheet with surface charge density this much. I consider that this plane sheet mentioned here is non-conducting. You see, many times what happens is that in the question some kind of ambiguity remains, okay, and we have to understand these things. We cannot do anything in the exam, we have to understand. So we have to assume that this is non-conducting, okay, and if it is non-conducting, then it will be equal to this one, sigma by 2 epsilon naught. And we know that electric field due to infinitely large sheet is independent of the distance. It does not depend on distance. It gives uniform electric field in both sides. Alright, now next one. Electric field outside uniformly charged spherical shell, surface charge density is sigma and radius r. Well, I think this will be this one, okay. Option 4, but this is dimensionally incorrect because I think some r will be here, okay. Alright, so C will go with 4. And what about the D? Electric field between two oppositely charged infinitely plane parallel sheets with uniform surface charge density. So this situation is nothing but parallel plate conductor, okay. You can consider the parallel plate conductor, although it is not infinitely large sheet, but still you can consider it to be sufficiently larger, and therefore electric field inside or in between the plate is equal to sigma by epsilon naught, okay. So this is 1. So option 4 is the correct one. Let's move to the next question. Again we have one question where we don't have to do any numerical. Work done in an adiabatic process, okay, for an ideal gas depends on what factor? Well, let's write down the work done formula. Work done formula is number of moles multiplied by molar gas constant, then this change of temperature or decrease of temperature divided by gamma minus 1, okay. So work done depends on the change of temperature, okay, it depends on change of temperature, right. So let's move on. Alright, we have again one numerical problem where we have to calculate, simple question, we have to calculate one torque. The coordinate of a particle with respect to the origin of a frame is given by this one, okay, and on this particle some force is acting which is given by this one. Now we have to calculate the magnitude of torque along the z-axis. We do not have to calculate the complete, we do not have to answer the complete torque, we have to answer only the z component, only z component of the torque. Okay. Well, we have to calculate, right? So first of all, what is the distance or the displacement? These coordinates are given, so this will be I cap, 1 I cap plus 1 j cap plus 1 k cap, and force is given. Let me write down the force. Force is equal to I cap minus j cap plus k cap. Now what is the value of the torque? Torque is a vector quantity and it is given by r cross f. So we not only will calculate the value of the torque, we will also calculate the direction of the torque in this way. Okay. So let me do it. So this is I cap, j cap and k cap. Let me put the values 1, 1, 1. This is 1, minus 1 and plus 1. Well, so this is equal to, what is I cap? For I cap, 1 into 1, 1 minus 1 into minus 1, minus 1 into 1 minus 1, that will be plus 1. Okay. All right. Then for j cap, 1 into 1, 1 minus 1 into 1, this is, and for k cap, 1 into minus 1 minus 1 minus 1 into 1, 1 into 1, this is 1. So this will be equal to 2 I cap minus 0 minus 2 k cap. Okay. But we have to calculate only the z component. Okay. And what is the z component? The z component is this one. Okay. So z component of the torque is equal to minus 2 k cap. So what is the magnitude? The magnitude is equal to 2. So this is 2. Okay. Now let's move to the next question. Again, we have one assertion reason question. Let's read the statements. Electromagnetic waves are energy, but electromagnetic waves have energy but not momentum. This statement is incorrect. Electromagnetic waves will have energy as well as momentum. Energy is given by h nu and the momentum is given by energy divided by c. Okay. All right. Mass of a photon is equal to 0. Yes, this fact is correct. So assertion as a statement is incorrect, but reason as a statement is correct. So what is the correct answer? A is false, but R is true. So this is correct. Now let's move on. All right. This is a question, I think, from kinetic theory of gas. What is given? For a fixed volume of gas, okay, at temperature 27 degrees centigrade, right? If we want to make the pressure of the gas double, then what should be the temperature? By what temperature we should increase? By what temperature? By what unit we should have to increase the temperature, or what should be the temperature corresponding to double pressure? Okay. So when the pressure is, let's say P1, the temperature is T1 and temperature is 27 degrees centigrade. So if I convert this into absolute value, this will be equal to 300 Kelvin. Okay. Now if the pressure is double, then what is the temperature? Okay. And the volume is constant. Volume is fixed. So if I consider the ideal gas equation where volume is fixed, so P is proportional to T. How? You see, for ideal gas, PV equal to nRT, right? So P is proportional to T. Therefore, I can write P2 divided by P1 equal to T2 divided by T1, right? Now put the value. This is 2P and this is P1 equal to T2 and this is T1. Or simply T2 is equal to 2 multiplied by T1. So this is 2 into 300, which is 600 Kelvin, But the answer have to be in terms of centigrade. Okay. So if I subtract 273, this will be equal to 327 degrees centigrade. So this will be 327 degrees centigrade. Okay. All right. So what is the next question? In this question, we have one hydraulic lift. Okay. And we know that in hydraulic lift, we do mechanical work. We apply force on one piston and because of the equal pressure, the through the other piston the object will be lifted. Okay. Now if I want to draw the hydraulic piston or lift, what is given? The surface area of the input piston is equal to 6 centimeter square and output piston is 1500 centimeter square. If we put 100 Newton of force to the input piston, then output piston moves up by 20 centimeter. Okay, and in this process what is the work done? That's the question, right? Let me explain again. We will apply some force which is equal to 100 Newton here. Okay, 100 Newton. What is the area of cross section? This is equal to 6 centimeter square, right? This is the output piston. Since we have applied the force in this piston will go up. This piston will go up with certain amount of force. And according to the question, this piston goes up by a distance of how much? 20 centimeter, or simply 20 into 10 power minus 2 meter. Okay. The question is, what is the work done? Now, work done involved is equal to force multiplied by distance. Force is upward, distance is also upward. So, Fs cos 0 Fs. To calculate the work done, we need to know the force first, right? So, what is the force? Well, according to the Pascal's law, F1 by A1 should be equal to F2 by A2, right? So, this is 100 and area is 6 centimeter square. This force has to be calculated and this is 1500 centimeter square. I am not converting this centimeter square into SI unit, that's because it will be cancelled. Okay, it is in the ratio form. So F2 is equal to 1500 divided by 6 multiplied by 100. Okay, so this will be equal to 250 into 100. So this is equal to 25000. So this is 25,000 Newton. 25,000 Newton. Now I will put this value here, 2500 and then 000, 20 into 10 power minus 2. Then this will be equal to 50 10 power minus 2. So this will be equal to 5000 joule. Okay, but the answer is given in terms of kilojoule, and therefore this will be equal to 5 into 1000 joule. So this is 5 kilojoule. So answer is 5 kilojoule. Okay, answer is 5 kilojoule. Now let's move to the next question. I think this is the last question. Let's read the question. So according to the description given in the question, there is a boat. Its speed in still water. In still water means when water is not moving, the maximum speed of the boat can be 27 km per hour. Okay. Now this boat is moving downstream. Downstream means along the stream. Okay. Downstream means along the stream, and the stream is flowing at a speed of 9 km per hour. And from the boat, a man throws a ball vertically upward with a speed of 10 meter per second. Okay, and then the ball will, of course, it will strike the ground or the river, the horizontal plane, I mean. Therefore, what is the range or the distance along the horizontal direction the ball has traveled, that we have to calculate. Okay, so first of all, what is this net speed of the boat? Let's calculate. So let's say this is the boat. The stream is moving with a speed of 9 km per hour, and the boat itself is moving with the speed 27. So the speed of the boat will be equal to 27 plus 9 equal to 36 km per hour. Let me convert this into SI unit. So 36 into 5 by 18. So this is 10 meter per second. To convert the kilometer into meter per second, we have to multiply 5 by 18. Now see, I will draw the boat again here. The boat is moving with what speed? 10 meter per second. Okay. Now a ball is projected in the vertical direction. Let's say vertical speed is uy and it is equal to 10 meter per second. But at the point of projection, ball already had the horizontal speed. Yes or not? Ball already had the horizontal speed, which is the speed of the boat. The speed of the boat itself is the horizontal speed of the projectile. And in addition to that particular speed, the ball was given a vertical push with a speed of 10 meter per second, and since it has both the components, it will follow this kind of path, inclined projectile path. And what is the range? The horizontal distance is called range. We have to calculate this range. So this is simply inclined projectile or oblique projectile. Tell me what is the range? The range is equal to horizontal speed multiplied by time of flight. In case of inclined projectile, the time of flight is 2 times the vertical speed divided by acceleration due to gravity. Let's put all the values. 10 equal to 2 multiplied by 10 divided by 10. So this is equal to 20. So answer is 20 meter. But the answer is given in terms of centimeter. We will convert this into centimeter by multiplying 100, and therefore the answer remains 2000. So I think whole discussion is over. Thank you.